Hello, thank you for watching, and in this screencast we're going to go through the following example of graphing an ellipse. So this is meant to help you guys get through your classwork assignment for the day while I'm at retreat, and we'll just jump right on in. First thing I notice is that the bigger denominator is under the y variable, so I know this one's going to be a vertical ellipse. Okay, it's going to be up and down. The major axis will be going up that far, and the way that I'm going to figure out how far up and down to go is, remember, I'm going to take the square root of that number. Now if you think about it, the square root of 15 is really close to the square root of 16. Okay, so it's just going to be a little bit less than 4. Okay, and just so bearing that in mind. Now, also, when we talk about where the ellipse is actually going to be graphed out at, it's nice to know about h and k, and it's the opposite of what we see there. So our h value is going to be 3, since I see a minus 3. Our k value, similarly, is going to be 1, since I see a negative right there. So 3, 1, let's move over 3 units to the right and 1 unit up, and that's going to be my center. Okay, and then as I said, we're going to go square root of 15 up and down, so that's just a little less than 4. So we're going to go up 1, 2, 3, 4, and just a little less than that. It's on the on the picture here. We'll put a little dot right there, and then similarly, we're going to go down 1, 2, 3, 4. A little less than 4 will go down. Okay, and then the same thing with our b value. It's under the x variable. B squared is 5, so we're going to go to the right square root of 5, which is just a little bit more than the square root of 4. All right, so which is just a little bit more than 2. Okay, so h and k equal 3 and 1. A and b equal square root of 15 and the square root of 5, respectively, right? So now I can just connect the dots right here with a nice smooth curve and sketch out my ellipse. Okay, now the question then becomes, okay, well, what are the coordinates of each of those points? All right, and if you think about it, I'm going to zoom in here to my graph. If you think about, what did we do? We went from the center, which was at 3, 1, and we went up. So we added to that y value. So 3, 1 plus however far we went up, in this case square root of 15. Okay, again, when we're moving in the upward direction, we're adding to that y coordinate, right? So from the center where we went up and down, so when I go down, I'm going to subtract from that y coordinate. Okay, so here we've got 3, 1 minus the square root of 15. And we will have talked about that in class on, I believe, on Wednesday. So this notion of adding and subtracting to and from a coordinate should make pretty good sense. When we move to the right, that's as though we're adding to the x coordinate. So instead of 3, it's going to be 3 plus square root of 5, right, for the x coordinate. The y coordinate doesn't change there. And then when we're moving to the left, what do you think? When we're moving to the left, we're going to be subtracting. Deleted a little bit of that on accident. We're going to be subtracting, so it's going to be 3 minus the square root of 5, 1. Okay, those are the endpoints of our major and our minor axes. I'll do the major axis here in red. Again, it connects the two vertices right there, and then I'll do the minor axis in green, and again it connects the two what are called the covertices, if you see those words used, right? And we know the center from our h and our k. The only other question that we haven't talked about just yet are, where do our focus points occur? And I'll put a black mark right there. Our focus points will always occur, right, on the major axis. And you and I in class have talked about how we can draw out a right triangle, okay, where the focus points are found. So here's my a value, here's square root of 15, here's my b value, square root of 5, and I want to know, well, what's that c value? Okay, so in other words, there's the right triangle that we talked about in class on Monday, where we're just using the Pythagorean Theorem to find that other side. Okay, now thankfully I gave you guys a shortcut, and if you paid attention in class, you already are probably thinking along those same lines, but remember, your shortcut just says take the bigger denominator, subtract the smaller denominator, and take the square root of the result. So in other words, 15 minus 5 equals 10. So I know my c value is going to be the square root of 10. If you wanted to use Pythagorean Theorem to solve for that and be my guest, you've got c squared plus square root of 5 squared equals square root of 15 squared. And so those square roots cancel out, and we've got c squared plus 5 equals 15. We're going to subtract 5 from both sides, and we get c squared equals 10. Again, c equals square root of 10 in that case, okay? So suffice it to say, I like the shortcut a lot better. Just big denominator minus little denominator, take the square root of the result. And that's going to, as I zoom back into our picture now, that's going to tell me what the distances that I'll need to scoot up and down on the major axis. Okay, I'm kind of clearing out a little bit of this clutter right here. So we will have scooted up, so we won't change the x-coordinate of the center. We will have scooted up, and so it will be 1 plus square root of 10. And then when we get to the center and go down, it will be 3, 1 minus square root of 10. Okay, again, because we're moving in the downward direction, so we affect that y value, we change it. So you can really tell that it's important for a problem like this to figure out what is my h value, what is my k value, and then to either add if you're moving up or to the right, subtract if you're moving down or to the left. And those are the pieces of information that we're asked to find. We're asked to find the focus points, the vertices or the endpoints of the major axis, and then the covertices, the endpoints of the minor axis. If you have any questions about that, feel free to either send me an email or let me know in class tomorrow. And for the rest of class today, you guys are to work on the other questions from that worksheet. And again, good luck, and I thank you for watching this video and taking the time to do some good work in class.